Are you aware of the many surprising connections between the deepest parts of space and the deepest recesses of our ocean? Both are cold, dark realms where humans cannot breathe and where the pressure alone is lethal. Both defy our normal experiences of gravity, offering explorers a strange weightlessness or buoyancy if they could somehow survive being there. And both are filled with unsolved, captivating mysteries. Hello and welcome to Zed. Please don't forget to subscribe and hit the bell icon. Our oceans contain life we've never seen, and who can say what lurks in the unexplored corners of space? I was initially surprised when I heard that NASA had turned its focus towards exploring the Hadal zones deep in the ocean. After all, NASA is typically about space. What are they doing deep under the water and on Earth? I'm Alex Mullen and you're watching Astrum. Put on your diving gear here and join me in a world of undersea facilities, uncanny life, in an environment so hostile we've mapped more of Mars than of this terrain on our own planet. In 1957, a year before NASA was founded, a paper published by the Journal of the Royal Society of Arts claimed the deep oceans cover over 2/3 of the Earth's surface, and yet more was known about the shape and surface of the Moon than about the bottom of the ocean. This was because, before echo-sounding technology was common, we didn't know much about the seafloor's topography. We've come a long way since then, but while we have mapped the Moon thanks to satellites and telescopes, we have only mapped 23.4% of the ocean floor in high resolution. In fairness, this still represents an area of 120 million square kilometers, about 3 times the Moon's surface area, so the old saying no longer holds entirely true. Hence why we can instead talk of Mars, which has a surface area of 145 million square kilometers. But still, it's a profound gap in our knowledge of our own world. NASA was founded in 1958 to expand human knowledge of phenomena in the atmosphere and outer space and to develop vehicles and technologies that would help them do so. Exploring the ocean was not originally on their radar or sonar. However, in 1978, NASA began monitoring the ocean with their first dedicated oceanographic satellite, CSAT, which collected data on sea surface winds, surface temperatures, wave heights, and other features. This helped them learn more about our planet's oceans and their impact on the global climate. Still, some of NASA's most exciting forays into the ocean only began at the turn of the millennium. One way the sea can prepare astronauts for space is through simulated space experiences. About 8.7 kilometers off Key Largo in Florida is the world's only undersea research laboratory, Aquarius Reef Base. Built in 1986, it is a small 3-roomed habitat, large enough to house 6 people, with a main room that combines sleeping and living quarters, an entry dock, and a wet porch for entering the sea around it. It was originally designed to help aquanauts remain at the bottom of the sea for weeks at a time through a technique known as saturation diving. By remaining at the depth of 19 m, the human body becomes saturated with gas dissolved in its bloodstream, allowing researchers to stay at depth without ill effects for much longer periods, 9 hours for one dive rather than 1 or 2 hours. This made it ideal for biologists wanting to study the local environment in situ. In 2001, however, NASA, along with other space agencies such as ESA, realized it made a great space training location. The cramped living conditions mimic those on the International Space Station, so astronauts who spent a week at Aquarius Reef Base got a vital taste of what life would be like up there. It also allowed them to practice performing experiments and generally get used to the expected and unexpected aspects of life in a hostile environment. NASA began the NEMO program, or the NASA Extreme Environment Mission Operations, and that same year began sending astronauts to the habitat. There have been 23 NEMO missions since then, merging astronaut crews from different space agencies, lasting up to 3 weeks. Astronauts there became aquanauts and got the chance to don deep-sea suits, getting a taste for what spacewalks might be like outside of our planet, readying them for the day humans return to the Moon or go to Mars. This was not the only use NASA had for the ocean. Perhaps the most significant training was not for NASA's astronauts, but rather for the machines that would one day visit the largest oceans outside of planet Earth. Let's now go deeper and consider the exploration of alien oceans. Our solar system is home to many large oceans outside of Earth. Jupiter's moon Europa and Saturn's moon Enceladus, to name just two, have significant bodies of water beneath their kilometer-thick icy surfaces. Despite only being 1/4 of Earth's diameter, scientists believe Europa holds twice as much water as all of our oceans combined. This is an intriguing concept, as even though no sunlight penetrates down to those depths, the mixture of liquid water bordering a rocky inner crust would make both locations ideal candidates for life. Scientists have considered how to best test for life in the oceans of icy moons. In 2024, NASA will launch the Europa Clipper to fly by Europa and scan it to learn more about the depth of its icy shell, try to determine the composition of its oceans, and get a better picture of the Moon as a whole. However, Europa Clipper will only lay the groundwork for future missions, which might see cryobots melting through the 10 kilometers thick icy shell of Europa using nuclear-powered radiators to penetrate its oceans and see firsthand what lies below. Once down there, no radio signal will easily reach them. Messages will be relayed via a vast cable brought down through the ice along with a cryobot. This means cryobots will need to autonomously descend a further 100 to 200 kilometers to explore the dark, chilling, and highly pressurized environment they're likely to find, to see what alien life might swim in those waters. So with a mission objective on the horizon to explore deep, dark waters in search of never-before-seen life, what better place to start than the unexplored oceans we already have at home? The deepest parts of Earth's oceans are only 11 kilometers deep, but due to the gravitational differences between Europa and Earth, the pressure you'd experience between the two is more comparable than you might think. Europa's 100 kilometers deep ocean is thought to have a hydrostatic pressure between 130 to 260 megapascals, which if it existed in an ocean on Earth would equate to a depth of around 13 to 26 kilometers. This is much better than going hundreds of kilometers down on Earth, but it's still no picnic. Pressure at the bottom of the Mariana Trench, the deepest place in our ocean, is 1,100 times the pressure on the surface, enough to crush human cells or implode most submarines. And yet life survives there, and it doesn't just survive, it thrives. The deep-sea explorers of the Galapagos, with especially reinforced remotely operated vehicles that could survive those pressures, were shocked to discover not a barren wasteland, but thriving ecosystems gathered around hydrothermal vents on the ocean floor. Down there, tube worms, crabs, and fish were found in rich abundance. As scientists performed more dives, they found all manner of strange life forms, shrimp-like amphipods the size of your hand, giant ethereal bigfin squid that were 8 m long and looked positively alien. In the depths between 6,000 and 11,000 m, in an area known as the Hadal Zone, named after the god of the underworld Hades, life had adapted to conditions in ways no one could have imagined possible. This incredible adaptability gives scientists a better understanding of what might be possible on other worlds. The deepest parts of the ocean are mostly found near the fault lines of continental plates, where one plate subducts under another. These deep trenches create a unique V-shaped environment that channels organic debris from above down into a sludgy pool. Whenever a carcass falls down there, the organisms in the Hadal Zone can quickly detect it and arrive within minutes. Other organisms rely on nutrient-rich liquids pumped out of thermal vents. If you added up all these trenches into one land mass, you'd end up with an area the size of Australia, a whole unexplored continent. NASA wants to explore these regions using autonomous drones, perhaps whole swarms of them, that would be able to detect locations of interest such as thermal vents and would map out the terrain using cameras and onboard AI similar to that used by the Perseverance rover on Mars. It's a challenging task. Not only would such a drone need to withstand the excessive pressure, but the temperature around such thermal vents can spike to hundreds of degrees. Drones would need to survive rapid temperature swings if they are to succeed. In 2014, one such deep-sea drone known as Nereus was sent into the Kermadec Trench off the coast of New Zealand. This is the area NASA has selected as a testing ground for its new equipment. However, sadly, Nereus was not able to survive the pressure down there despite having succeeded on Hadal dives before, and it imploded. Pieces of plastic were later found floating to the surface. NASA's latest drone is Nereus. Thank you for watching and see you next time.